Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of JEE Main, we're going to be looking at previous year questions of physics asked in engineering entrance exams in India. Today we're dealing with one of the first and foremost chapters asked in these exams, and that is units and measurements. So in units and measurements, we're going to be talking about dimensional analysis, various units for physical quantities, measurement of quantities, accuracy, precision, etc. So we'll try to cover most of the questions asked in this chapter in this video. So let's look at our first question. Identify the pair whose dimensions are equal. Well, here we have four options: torque and work, stress and energy, force and stress, force and work. So in this question, it makes sense in order to write down the dimensions of each quantity given here. So you have force. Force, we can write it as mass times acceleration. So therefore, it is basically mLt power minus 2. This is the dimensional formula for force. If you take the dimensional formula for stress, then stress is basically force divided by area. So that means you get ml raised to minus 1t raised to minus 2 as the dimensional formula for stress. Now what about work? Work is basically force times displacement. So mlt power minus 2 times L, so that is mL square t power minus 2. Energy, the dimensions of energy are the same as the dimensions of work, so that is mL square t power minus 2. And then finally you have torque, and torque is basically the moment of force, so that is calculated as force times linear distance. So again, the formula for torque is mL square t power minus 2. So these are the dimensional formulas of the 5 quantities. So if you look at option D, which is force and work have different dimensional formulas, so option D is incorrect. Option C, stress, also has the same problem. Force and stress do not have the same dimensional formula. If you look at stress and energy, stress is ml raised to minus 1t raised to minus 2, while energy is ml squared t raised to minus 2, so option B is incorrect. The right answer is option A, torque and work. So you can see work is ml squared t power minus 2, torque is also ml squared t power minus 2, so both their dimensions are the same. So option A is the correct option for this question asked in 2002. Let's move on to the next question. Dimensions of 1 by mu naught epsilon naught, where symbols have their usual meaning, are: is it L raised to minus 1t, L raised to minus 2t t squared, L squared t raised to minus 2, or LT raised to minus 1? So here the symbols have their usual meaning. So mu naught stands for permeability in free space, magnetic permeability, and epsilon naught stands for electric permittivity in free space. So there is a formula which relates the two quantities, and that is the formula with respect to velocity of light in a vacuum. So the velocity of light in a vacuum is c, which is a symbol that is equal to under root of 1 by mu naught epsilon naught. So velocity has the dimensional formula LT raised to minus 1, and the right hand side is equal to 1 by mu naught epsilon naught under root. So basically we now square both sides. So when you square both sides, you get LT raised to minus 1 whole square equals 1 by mu naught epsilon naught. So therefore 1 by mu naught epsilon naught will be equal to L squared T raised to minus 2. So among the following options, option C is the correct option to this question asked in 2003. The important thing to note is that we use the velocity of light in a vacuum, which we usually study in the chapter magnetism and moving charges and magnetism, as well as magnetism and matter. So in these chapters we study about this formula. We applied that here and put in the dimensions of light's velocity, so therefore we get L squared T raised to minus 2 as the correct answer. Next question. The physical quantities not having same dimensions are. So here we have some physical quantities. We need to find out which of these do not have the same dimension. So option A, torque and work, is anyway incorrect because in the previous question we found out that both of them have the same dimension, which is ml squared t power minus 2. Now, among the given options, you have option D, speed, and mu naught epsilon naught raised to minus half. So light is LT raised to minus 1, mu naught epsilon naught raised to minus half. That will be equal to L raised to minus 2 T square whole raised to minus half. So it's basically LT raised to minus 1 on calculation. So therefore speed and mu naught epsilon naught whole raised to minus half will have the same dimension. So option D is incorrect. What about option C, stress and Young's modulus? In the previous question we noted that stress has the dimensions ml raised to minus 1, t raised to minus 2. And Young's modulus, it also has the same formula, ml raised to minus 1, t raised to minus 2. So therefore option C is also incorrect. The right answer is option B, momentum and Planck's constant. Now, to check it out, momentum is mass times velocity, so you have mlt raised to minus 1 as the dimensional formula for momentum. And for Planck's constant, h, you get m L squared t raised to minus 1. So this is the actual dimensional formula for Planck's constant. So therefore, as you can see, momentum and Planck's constant, they do not have the same dimensions. So option B is the correct option. Note that the dimensions of Planck's constant are equal to angular momentum, because in angular momentum you are basically multiplying momentum with distance, so therefore you get ml squared t power minus 1, so whose dimensions are equal to the dimensions of Planck's constant. Let's look at this question. Which one of the following represents the correct dimensional equation for coefficient of viscosity? So which of these dimensions are correct with respect to coefficient of viscosity? So in this question, again, we need to use a general formula. So we will use the formula for viscous force. So according to Stokes' law in mechanical properties of fluids, the viscous force F is equal to 6 pi times eta times R times V, where eta stands for coefficient of viscosity, R stands for radius, and V stands for velocity. So from this formula, you can write eta, that is the coefficient of viscosity, as equal to F divided by 6 pi RV. So when you are taking dimensions, you will get the dimensional formula for coefficient of viscosity as dimensional formula for force divided by the product of the dimensional formulas of R and velocity. So the reason why we ignore 6 pi is because it's dimensionless, so you don't need to include it when you're calculating dimensions. So when you're calculating dimensions, the numerator is mlt power minus 2, and the denominator is L times lt power minus 1. So mass stays the same. When you're talking about length, that's 1 minus 2, so L raised to minus 1, and t raised to minus 2 minus of minus 1, so that is t raised to minus 2 plus 1 is equal to t raised to minus 1. Again, following laws of integers in order to solve that. So the correct dimensional formula for coefficient of viscosity is ml raised to minus 1 t raised to minus 1. So among the 4 options, you can see that option C is the correct option. Next question. Out of the following pairs, which one does not have identical dimensions? So which of these have different dimensional formulae? Let's find out. So option D is impulse and momentum. These have the same formula, which is ml t power minus 1. So momentum is mass times velocity, so you get that dimension. And impulse is force into time, so therefore ml t power minus 2 times t, so that becomes ml t power minus 1. So both impulse and momentum have identical dimensions, so option D is incorrect. And according to our previous question, Planck's constant has ml square t power minus 1, and the formula is similar to that found during angular momentum. So the dimensions of angular momentum are identical to the dimensions of Planck's constant. So option C is incorrect. What about option B, work and torque? Once again, in our previous question, we know that work and torque have the same dimensions, which is ml squared t power minus 2. So this is the same dimensional formula for both work and torque. So option B is incorrect. The right answer is option A, moment of inertia and moment of a force. So if you look at this question asked in 2005, what makes this option correct? Moment of inertia, which you normally represent as I, is written as mr squared, the formula. So the dimensional formula will be mass times length square. If you take moment of a force, that is C, that is written as force times displacement, so it's basically torque. And so therefore the dimensional formula for C is ml squared t power minus 2. So as you can see, both the formulas are different, so they do not have identical dimensions. Therefore, option A is correct for this question. We were asked to find out which of these do not have identical dimensions. Let's look at this question. Which of the following units denotes the dimensions ml squared divided by q squared, where q denotes the electric charge? So if you have learned dimensional analysis, you would know that electric charge isn't one of the 7 fundamental units. So we have to convert charge and then find out the actual formula. So ml squared divided by q squared is equal to ml squared divided by a squared t squared. So that is equal to ml squared a raised to minus 2 t raised to minus 2. So this is the actual dimensional formula of the quantity which we have to find out, that is represented as ml squared by q squared. So this is the actual dimensional formula, ml squared a raised to minus 2 t raised to minus 2. So if you look at Weber, that is option A, Weber has the dimensional formula ml squared t raised to minus 2 a raised to minus 1. So this is basically the angular work divided by the charge. So therefore option A is incorrect. If you look at option B, that is Weber by meter square. So basically you take the L out of the equation, the length out of the equation, because you're dividing by meter square. So therefore mt raised to minus 2 a raised to minus 1 is the dimensional formula for option B, which is again incorrect with respect to the question. So option D, Henry per meter square, has the dimensional formula mt raised to minus 2 a raised to minus 2. So therefore option D is incorrect. So Henry, the unit Henry, will have the dimensional formula ml squared t power minus 2 a power minus 2. So therefore option C, Henry, is the correct option. So we need to find out which of the following units denotes the dimensions ml squared by q squared. So the first thing to do is convert ml squared by q squared into ml squared a raised to minus 2 t raised to minus 2. Then find out which of these units is matching with ml squared t raised to minus 2 a raised to minus 2. In this case, that is option C, Henry. So option C is the correct option for this question asked in 2006. So now we've reached the final question of this episode. The dimension of magnetic field in mass, length, time, and coulombs is given as. So we have one of 4 options and we need to find out the correct one. Note that in this question we have to use the 4 quantities given to us. So you don't have to change coulomb into AT, that is ampere into time, because we have to find it using coulombs. So therefore this may not be standard, but we have to use the given units and then find out the dimension. So we need to find out the dimensions of magnetic field. So for that we use the formula of Lorentz force. So according to Lorentz force, the total force acting on a conductor is the product of the magnetic, according to Lorentz force, the magnetic force acting on a conductor is equal to modulus of QV cross B. So if you were to take the dimensional formula of this force, then that will be equal to dimensions of Q times dimensions of V times dimensions of magnetic field. We need to find the dimensions of magnetic field. So dimensions of magnetic field is equal to dimensions of force divided by dimensions of charge into dimensions of velocity. Force is mlt power minus 2 divided by Q, that is charge, which is represented in coulombs, and velocity is represented in lt power minus 1. So length gets cancelled. So the final dimensional formula for magnetic field in terms of coulombs can be given as mass t raised to minus 1 and c raised to minus 1. So this is the correct dimensional formula according to the question asked in 2008. And so therefore among the 4 options, option D, mt raised to minus 1, c raised to minus 1 is the correct option. So that concludes this episode of JEE Main. We hope you found this episode interesting. For more of our videos on JEE Main, you can always hit the link in the description down below. For getting more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.